So in the last video, we left off distinguishing between short run and long run costs. And what we're going to be doing is we're going to be looking at the short run and how costs change when you change output. So when there are fixed inputs, like I said in the last video, we're dealing with a short run production condition, right? And the short run is simply a time frame where at least one factor of production cannot be changed. So something is fixed. So we have a combination of fixed costs and variable costs. Labor tends to be the most variable input. So in other words, it takes the least amount of time to change labor. It takes a longer period of time to change something like land or physical capital. So let's look at how output changes when you changed a variable input, in this case labor, holding other factors of production constant. So here we have soup production. As you can see, soup production is right here. And here we have the different chefs, one chef, two chefs, three chefs. How many bowls of soup can we produce when we have a fixed amount of capital, and let's say one stove, and we hire more chefs? Well, you could see how things change. Remember how when we hired the first chef, he was able to produce 15 bowls of soup? Then we hired the second chef, total output went to 34 bowls. And the vertical distance between point B and point C is the second worker's contribution, 19 bowls, 34 in total. When we hired the third chef, output went to 44 bowls right about here. When we hired the fourth chef, output went to, I think it went from to 44 to 48, four more bowls, then two more bowls, then one more bowl, and then no change. If we connect these dots, this is our short run production function. It shows how fast output changes when you change labor. And I want to draw your attention to the slope of this line. When it gets steeper, that simply means as you add workers, output is increasing at a faster rate. When it starts to flatten, but still is moving upward, that means output, the change in output is slowing as you increase workers. And what we're basically measuring is we're measuring worker productivity. And the phrase that they use in the textbook is marginal physical product, MPP. And that's simply a change in output over the change in input. So if you tell me how much output has changed and how many workers you've hired, you could put in the variables here and out spits the worker's productivity, which is another words of saying MPP. And when MPP is positive, that simply means as you hire workers, output is increasing. Now, what we're really interested in is at the rate output is increasing. So if you hire another worker and MPP is growing, that's another way of saying productivity is increasing. If you hire another worker and MPP is falling, but still positive, productivity is falling. So again, here is the change in total output, and this is the change in the change. In other words, when you hire the 0 to 1 worker, the change in total output is 15. When you hire the second worker, we have an output of 34. The change from 15 to 34 is 19. Hire the third worker, output goes from 34 to 10, and the difference between these, okay, let me see. When you go from 2 workers to 3 workers, output grows to 44, and the change from 34 to 44 is 10. So this is a measurement of worker productivity. This is MPP, marginal physical product. Notice how marginal physical product is declining, but still positive. So for example, from 1 worker to 6 workers, MPP is positive. but it's falling from 3 workers to 7 workers. It's another way of saying productivity is falling. We can graph both lines. So the top line is the production function. This bottom line is simply measuring MPP. And what's fascinating is when you go from 0 workers to 1 worker to 2 workers, productivity is increasing. In other words, the total output line is steepening. And that's another way of saying MPP is increasing. As you can see from A to little b to little c, the MPP line is going up. That's another way of saying productivity is going up. But as you go beyond 3 workers, notice how the total output line is flattening. That's another way of saying that the change in output is diminishing. The increase is diminishing. That means the MPP line is starting to slope downward. Productivity is falling. So output is going up, but it's going up at a slower rate. That's another way of saying productivity per worker is falling. Now, the reason why this is happening is the official term is diminishing marginal returns. That's a fancy way of saying is as you hire more workers, but you're keeping the amount of the stoves constant, the size of the kitchen constant, each additional worker is going to give you less and less in terms of output because each additional worker has a smaller ratio or smaller access than previous workers. The best analogy is when you work in an office and you have to share a copy machine with other workers. When you need to make copies, somebody may be in the process of doing a large copy job before you. While you're waiting to make your copies, you're not very productive. And the reason why you're not productive is because you have to share the machine, the copy machine, with others. That's another way of saying you're sharing physical capital with other workers. And the more workers that has to share that copy machine, the lower the productivity per worker. So as more worker labor is hired, each unit of labor has less capital and land to work with. And output begins to rise at a more and more slowly as more workers are hired. And again, this is basically called the law of diminishing returns. Now, let me remind you, let me just back up. If we're paying all of these workers the same wage, you could see how unit labor cost, unit labor cost is the output produced by a worker divided by that worker's wage. Well, if you've got MPP, that's workers' productivity, divided by wage, which is unit labor cost. If MPP is falling, as you see here, see how MPP is falling, but wage is being held constant. Well, if the numerator is falling and the denominator is staying the same, unit labor costs must be rising, right? And that's a big reality when it comes to measuring costs in the short run. So let's look at the costs we have to deal with. The first cost we're going to be talking about is total cost, marginal cost. Now, whenever you see the word marginal, marginal is a before and after analysis. What were my costs before I hired the last worker? What are my costs after hiring the worker? That change in cost is the marginal cost for the last worker hired, or the change in cost for the last unit produced. And that's simply the change delta right here, delta, the change in total cost over the change, delta again, in output. So we see a relationship between productivity, MPP, and marginal cost. In other words, whenever MPP is going up, when MPP is going up, marginal cost must be falling. So when workers are more productive, marginal cost is falling, and the vice versa. When MPP is falling, when workers are less productive, marginal cost is increasing. Let's look at this. On the left-hand side is MPP. As you can see, MPP is rising for the first 2 workers. It's going up. Then beyond 3 workers, it starts to fall. Well, what we see here, for the first 2 workers, marginal cost is declining slightly, and then beyond 3 workers, it's going up. So you can see why companies are so focused on controlling costs, because not only are costs going up, they're going up at a faster and faster rate. So for the next video, what we're going to be doing is we're going to be looking at all the different categories of costs. Total cost, variable costs, fixed costs, and all of the average costs. That's going to be in the next video.